Well, this is from 2015. Okay, this is from 2015. Suppose a limit as x tends to infinity, x squared plus 1 upon x plus 1 minus ax minus b is 0. Then a cube minus b squared is negative 1, 0, 1 and not determinable. Okay, now not determinable could also be an option here, because it may appear to us that we have only one equation at our disposal and we have got two unknowns, a cube and rather a and b basically. Okay, but don't mark it, because unless we solve it we will never come to know. Okay, yeah. Now one key point which you should take away is limit is existent. Limit exists, which means if by some means we could write it in one polynomial by other polynomial form, we can apply the rule, right? So let's go for it. Let's take the denominator here, x plus 1, x squared plus 1 will remain. Now we have to multiply negative ax minus b by x plus 1. So minus ax squared minus bx minus ax minus b. Okay, and this is 0. So far we have not done anything. Okay, we have just brought that ax b thing in numerator. Now observe degree of denominator 1, degree of numerator 2. Now this contradicts with the existence of limit, because we clearly know if x is tending to infinity and we have got a rational function with numerator's degree greater than that of the denominator, then the limit cannot exist, like, or we write infinity there or negative infinity, but definitely not finite. But here the limit exists and is finite. Limit exists and is finite. Therefore, what we must conclude? Therefore, degree of numerator must be 1. Same as that of denominator. Okay? And therefore, 1 minus a is 0 and therefore a is 1. How did we get that? How did we get that? Look, x squared is there, minus a squared is there, minus ax squared is there. Coefficient of x squared should be 0 because degree of the numerator must be 1. Therefore, a is 1. Okay, but that's only half of the problem. Now you have understood that because we have determined a and we still have to continue solving the problem, option D may not be the right. Option D may not be the right option. Okay, option D may not be the right option. Therefore, we get, what do we get? Limit x tends to infinity 1 minus bx minus x, now I can write because a is 1, minus b upon x plus. Now can we apply the L'Hospital's rule? We can, because it is definitely in infinity by infinity form. Could be negative infinity, but that hardly matters. Okay, so what does L'Hospital give? To it, denominator is 1, 0, minus p, okay, minus p minus 1. Okay, don't write this b because it is a constant, so its derivative is 0. Okay, so what have we got? Negative b minus 1 is 0, so p should be negative 1. We've got p as well. So what will a cube minus b squared be? A cube 1, b squared 1, a cube minus b squared is 0. Okay. Have you understood this? Or Uh, got it, right? Okay, cool. So see, look, because the limit exists, we can conclude that the numerator's degree has to be equal to that of the denominator. Can't even be less than that. Or can it be less than that? Uh, it could be less than that, but mm, in that case, okay, let's just consider that possibility. Although I don't think the problem setter intends to do that, but let's quickly go for it. Okay, because anyhow the limit is 0. What if, suppose, what if the degree of numerator were 0? Okay, what if the degree of it, because see, that is a perfectly reasonable assumption. Why is it perfectly reasonable? Because look, x is tending to infinity and denominator is x plus 1, so denominator is anyhow an extremely large number. So if we have a numerator of the kind which has just a constant term, that would still mean that the limit is 0. So let's go for it. A's value won't be different. A's value would still be 1, right? But what about B? Okay, A plus B in that case should be 0, but that will also give us B as negative. Have you understood this? What did I do? I went for the coefficients of x now, okay, which are negative b and negative a. If we take the negative one outside, we get a plus b. We don't want the numerator to be of first degree, we want it to be a constant polynomial, basically a constant. So a plus b should be 0, that again gives us b as negative 1, essentially the same result that we got here. Correct? So even if we consider the other possibility, we still get the same answer. Okay, so yeah, that's question 6 for you.